Hello, good morning students. So in the previous class we completed the module 2, that is source coding. So in today's class we will be starting up with module 3, which is called as communication channels. So where in this module we are going to see how we are going to use different channels with error which is used for transmission of your information source. So now in order to know related to your channel, first let us know the block diagram of a communication system. As already we discussed in the module 1, the digital communication system block diagram. So here also we will be discussing the same thing, but here we are giving much importance with respect to your channel. So where, as you can see here, I have represented the communication system with a transmitter, a physical channel as well as a receiver. That means to say that in a simple communication system, so we have the three main components. So one is the transmitter, which is used for transmission of your data. Then a physical channel, which acts as a link with respect to the transmitter as well as with respect to your receiver. And we have a receiver which is used to receive the data which is being transmitted with respect to your transmitter. So now in general, so we have two types of signal. So one is analog as well as digital. So we know that all signals in nature are analog, and we need to have some technique for the conversion of analog to digital, where we have the sampling theorem, which is mainly used for conversion of your analog to digital signal by using different quantization techniques as well as different modulation techniques. So now here with respect to the channel also, we have analog channel as well as discrete channel. Analog channel in the sense which is also called as continuous channel. That means the signals are continuous in nature. That means here the channel what we are using here is an electrical channel. And we also have what we call as the discrete channel. Discrete channel in the sense it is going to consider input as the binary data and produce binary output. That is your discrete channel. So now what is a channel is? So channel is, in simple term, I can say that channel is a medium through which transmission of data takes place, or it is the medium through which the data is being transmitted, or I can say that it is the medium through which the data which is transmitted from the transmitter is being received with respect to your receiver. So this is about what do you mean by a channel. So next we have divided, or we have indicated some numbers here with respect to this block diagram. So where we have the modulation channel, then we have the coding channel, then we have the discrete data communication channel. So now coming with respect to this communication system, so we have the channel encoder as well as the modulator, which constitutes your transmitter. So as I already indicated that in your communication system, so we have three main blocks. That is, first with respect to the transmitter, we have the channel encoder plus the modulator. Then with respect to the physical channel, so we have the electrical communication channel, or what we call as the transmission medium. Then with respect to the receiver, we have the demodulator as well as the channel decoder. So where the channel encoder is the one which is going to encode the data, that means it accepts the binary input and it gives to the channel, and then the channel decoder is the one which is going to convert back the symbols into your binary output. Then we have coding or channel, or what we call as the discrete channel. So that means the points from 2 to 6. So it is from 2 to 6, we call them as the coding channel or the discrete channel, because here the input what we are going to consider for this coding channel, that means from 2. That means your modulator is going to accept the data from the channel encoder, where the input what we are applying here is your symbols. That means symbols in the sense I can say that it could be your letter A, or I can say that a set of characters, or I can say that it is an information source what we are going to input or what we are considering from your channel encoder. Then we have the modulator, where it is going to modulate your data and gives to your channel, where your channel is a modulation channel. What we have used is an analog channel here. And then with respect to the channel, so we have some noise which is being introduced. Then we have the demodulator, where it is going to demodulate the data and then it gives to your channel decoder. That means the output of the demodulator, that means the input what we are inputting here is symbols, and the output what we are going to get here is also the symbols, and then it is given to your channel decoder to convert these symbols to your binary output. So that is the function of your coding channel, or what we call as the discrete channel. So discrete channel is the one which will be having the input as that means it will be considering the input as symbols, and it is going to produce some output as symbols. And then this channel data, that means the output what we are going to get, it gets modified due to the introduction of noise, or I can say that the error. So if suppose if you are inputting 0 and if you are getting 1 at the output, so then that is due to the introduction of the noise or the error with respect to your communication channel. Okay. So this is about the coding channel, or why we call it as a discrete channel. So that means it is going to accept digital data and digital data, or I can say that symbols as input and produces symbols as output, and with the introduction of noise or error with respect to your channel, the data gets changed, or there may be variations with respect to the output whatever you are going to receive. Then we have the discrete data communication channel. So the discrete data communication channel is from the point 1 to your point 7. So it is completely called as discrete data communication channel. So why it is called as discrete data communication channel means, here the input what we are going to input to your channel encoder is a binary output, and then whatever we are going to receive at the receiving end will be your binary output. That means the input as well as the output is binary in nature with respect to your discrete data communication channel. So that's why it is called as discrete here. So that is about your discrete data communication channel. Then we have the coding channel. Then we have one more which is called as the modulation channel. So modulation channel, which is continuous in nature, or I can say it is analog in nature. That means it is going to accept the data from your modulator, that is the symbols will be accepted and that will be converted to an electrical signal or an analog signal, and then it will be transferred to your demodulator and then to your channel decoder. That means the input to your channel or the transmission medium, so will be your analog signal what you will be inputting, and then you will be receiving at the output will be your, and at the receiving end the output will be in the form of binary. So that is regarding your modulation channel. Then we have the physical channel. So the physical channel is nothing but the medium. So now in the case of a transmission system, so what happens here is that, so there might be some impairments, or I can say that some disturbances which gets introduced to your channel. So as you can see in the block diagram, so we have represented or we have added a noise with respect to your communication system. So where the noise can also be called as one of the disturbance or error which is being introduced with respect to your channel. So the impairments are, there might be variations with respect to its amplitude, or it might be with respect to the frequency, or there may be some non-linearities with respect to the time, etc. So other than this variations, so there can be noises which gets introduced, where we are going to study different types of noise like short noise, thermal noise, and the errors such as burst error, random error. And other than this, so we can say that there might be fading of the signal. So these are some of the disturbances, or I can say the errors which gets introduced to your channel. So by the introduction of this error, what happens is that the channel capacity, that is channel capacity here is nothing but the maximum rate at which the transmission of data takes place. So we give much importance to this, that is your channel capacity with respect to your communication system. So channel capacity is nothing but the maximum rate at which the maximum amount of information can be transmitted by using your transmission medium. So if more number of errors get introduced, or the disturbances or the impairments, if it gets introduced to your channel, so then the channel capacity will be deteriorated, or I can say that the transmission limit, or the transmission capacity, or the channel capacity gets reduced. So that's why we have some theorems which we will be using. So where using those theorems, that means by the introduction of the errors, we can also have some way of errorless transmission. That means the channel capacity cannot be deteriorated. So we are going to retain the same channel capacity by using some channel capacity theorems. So, or in simple terms I can say that, so with error we are able to transmit the data with highest channel capacity. Okay. So this is about your communication system. So next let us see how we are going to represent a channel, and then how we are going to represent a noise diagram or a channel diagram, and also if we have inputted some data and with error, what you are going to get at the output. So let us look into how we can represent a channel. So the representation of a channel, it consists of an input as well as output. So let us consider here, an input alphabet A. Input alphabet A, so where it consists of the symbol A1, A2 up to AR symbols, and similarly it consists of an output alphabet B. So let us consider this B consists of B1, B2, Bs number of symbols. So where we have represented the input A with A1, A2 up to AR symbols, and corresponding to that we have the output symbol B. So where the input is represented in row wise, and output is represented in column wise. Okay. So where each of the input as well as output, so these will be represented in the form of conditional probability. So where P of Bj by Ai is called as, here P of Bj by Ai is called as the conditional probability. Okay. So why we have this conditional probabilities here is that it is due to the introduction of the noise or the error with respect to your discrete channel. So we have this conditional probabilities. Okay. So this is how we are going to represent a channel. So now this channel can be represented in the form of a channel matrix, or we can say it as a noise matrix, because the noise has been introduced with respect to your channel. So as I already told that, so we are representing this channel matrix or the noise matrix in the form of conditional probability, so which is represented as either P of Bj by Ai, or in general it is P of B by A, that is output by input. So we have A1 to AR input symbols, and corresponding to each of them we have the output B1 to Bs. So P of, so if we consider the first row, it is P of B1 by A1, B2 by A1 up to Bs number of symbols. So similarly, if you consider the input A2, so it will be B1 by A2, so P of B2 by A2, so up to P of Bs by A2. So this continues, so up to the last Bs as well as the AR symbols. So that means the representation in this form, that is R input into your S number of output symbols, that is R into S, which means to say that R represents your input, it is nothing but it is your transmitter, and your S represents your output, that is nothing but it is your receiving end, or we can say that it is the reception or the receiving end. So that means, so R into S number of symbols are represented in the form of conditional probabilities with respect to your channel matrix or the noise matrix. Okay. So now let us see an example of, if suppose if an error get introduced, so then how the output gets varied depending upon the input. Okay, let us now look into the channel diagram or the noise diagram. So where I have considered three inputs here, A1, A2 as well as A3, and corresponding to the inputs what we are applying, so we have received 4 outputs. So but we are inputting how many number of inputs here? So we are inputting only 3 inputs, but we are receiving 4 outputs due to the error which has been introduced with respect to your channel. Okay. So let us represent A with value 0, 0, 0, 1, 1, 0. So similarly your B1 is 0, 0, 0, 1, 1, 0 as well as 1, 1. So this is how you are going to represent the channel diagram. So where we have 3 inputs what we have considered here, that is A1, A2, A1, A2, A3 are your inputs what we have considered, and corresponding to that we have received B1, B2, B3 and B4 are your outputs. So if suppose if there was no error, then we could have received only 3 outputs, that is B1, B2 and B3. But since we have error with respect to your channel, so we have received 4 outputs, that is B1, B2, B3 and B4. So let us consider this is P11, this is your P12, this is P13 as well as P14. So now if we consider them, so they are represented in the form of the conditional probability. So here, so your A1 and B1, so that is it has been received, so we have inputted 0, 0, so but here what we have received, so here we have received correctly, that is 0, 0, but so here we have error, so here also we have error and here also we have error. So now if we are considering the diagram, so then we can represent in general in the form of, here we are representing in the form of conditional probability. So that is P of B1 by A1. So that is P11 is equal to, so P11 I can represent it as P of B1 by A1. So similarly P12 it can be represented as P of B2 by A1. Then similarly, if you want to represent P13, it is represented as P of B3 by A1. So similarly, P14 is equal to P of B4 by A1. So this is how we are going to represent them. So similarly, if we are going to represent this, so it will be P of 2. So this is P of 2, 1, P of 2, 2, P of 2, 3, P of 2, 4. So this, it is P of 3, 1, P of 3, 2, P of 3, 3, and this is P of 3, 4. So now the sum of all these conditional probabilities, so it is equal to 1. So if we consider any of the conditional probabilities, if you are going to sum them, you are going to get their value equal to 1. So in general, what I can write? So I can write this, that is the conditional probability, the summation varies from j is equal to 1 to s P of Bj by Ai. So considering this channel matrix, I am writing this standard equation for your conditional probability. That means to say that the sum of all the elements in any row of the channel matrix is equal to unity. Okay. So this is of how we are going to represent the channel diagram or the noise diagram. So similarly, if we have in general, if we have A1, A2, A3, so up to r number of input symbols, then P of A1 plus your P of A2, so up to P of AR is also equal to 1. That means the sum of all the elements with respect to your row. So that means by considering the sum of all the input symbols, their sum will also be equal to unity. Okay, the sum of all those input symbols what we have considered, that is A1, A2 up to AR number of symbols, in general it can be represented as I is equal to 1 to R, P of AI is equal to 1. So next we have how we can find here P of Bj by AI, that is the conditional probability, the input symbol as well as the output symbol is that. So by using the theorem of total probability. So by using this theorem of total probability, so given the channel matrix, you can find the conditional probability input as well as the output symbols. So now if you want to find the output symbol P of B1, P of B2 or up to Bs number of symbols, so this is how we are going to find. So P of B1 is equal to P of B1 by A1 into P of A1. So up to how many number of symbols we need to consider? Up to R number of symbols. So similarly up to Bs number of output symbols you need to find. So everything is found out in this way, that is P of B2 by A1 into P of A1. So up to P of B2 by AR number of symbols into AR. Okay. So this is how we are going to find the output symbols. And then next we have the condition. So we know how to find P of Bj by Ai. So if suppose if you want to find P of Ai by Bj, so this is the formula which we are going to use, that is P of Bj by Ai into P of Ai divided by P of Bj. So this is to find P of Ai by Bj. Okay. So now next topic we have what we call as the joint probability. So joint probability of A comma B. So how we are going to find P of Ai comma Bj? So P of Ai comma Bj can be represented in this form, that is P of Bj by Ai into P of Ai, or we can find out using P of Ai by Bj into P of Bj. So it depends upon whether what parameters you know. So if suppose if Ai is known, So you can use this formula to calculate your joint probability. And suppose if you know the output Bj, so then you can find, and you don't know the input Ai, so then you can use this formula to find your joint probability. So now how this P of Bj by A into P of Ai is found is written in the general form here. So P of Bj by Ai means it is written in the form of conditional probability. So since we have considered it in the first row, so it is so you are going to multiply the first row by A1. So this is your B1, this is your B2. So this is up to Bs number of symbols what we have considered here. So this is your output and this is your input. Okay. So multiply the first row by A1, then multiply the second row by A2. So this is P of Bs by A2 into P of A2. So this continues. So up to where it has to get continued. So it has to get continued up to A number of input symbols. So this is how we are going to represent your joint probability. So by multiplying the first row with A1, second row by A2 up to A number of symbols. So where in general I can represent in this form, that is P of Ai comma Bj is equal to P of A comma B, which is equal to, so where this can be written as A1 comma B1. So similarly the next one can be written as A1 comma B2. So this gets continued. So up to how many number of symbols we have to represent, up to Bs number of symbols with respect to the output and Ar number of symbols for corresponding input. So this is how we are going to represent your joint probability. So now the next topic is related to some small theorems what we are going to use it to solve the problem. So we have some properties of joint probability matrix. So where the first property is like this. So the first property is related to how we are going to find the output symbols. So P of B1, so which can be written in this form, that is P of B1 by A1 into P of A1. So that is multiplying the first row by A1. So up to how many number of symbols? Up to AR number of symbols. So where this can be written in the form of joint probability, that is P of A1 comma B1. So this is. So similarly the next term can be written as A2 comma B1. So this continues up to AR number of symbols. So in general what I can say is that, so addition of all the elements in the first column, that means by adding all the elements the column wise you are going to get B1. So similarly if you add with respect to B2 column wise, you will be getting what is the value of your B2. Similarly the value of B3. So that this continues up to BR number of symbols. So in general what I can write is summation of I is equal to 1 to R, P of AI can be AI comma Bj is equal to P of Bj. That means the sum of addition of all the elements in the first column we get B1. So similarly the sum of all the joint probability matrix, so is going to give you, that is addition of all the JPM column wise you are going to get the output symbols, that is P of Bj. So you are going to add or perform the addition column wise if we want to calculate the output symbols. So similarly we have the property 2. So where the property 2 it is going to find you the input symbols. So similar to your P of B1, so your P of A1 can be written as P of A1 by B1 into P of B1 plus P of A1 by Bs into P of Bs, since we have Bs number of source symbols with respect to the output. So this continues up to AR number of symbols. So this is AR by B1 into P of B1. So this continues up to AR and BS number of output symbols. So now this can also be written in the form of JPM, that is A1 comma B1 plus P of A1 comma B2. So this continues up to BS number of symbols. So if we consider for R number of input symbols, so it is AR comma B1 plus P of AR comma B2 up to AR comma BS. So in general what I can write is that the sum of all the elements, of your JPM. So the sum of all elements of JPM in row wise gives the input symbols. So that is, if you perform the addition in row wise, you are going to perform the input symbol. So it is summation of j is equal to 1 to s p of ai comma bj is equal to p of ai. So we have the property 3, so where it is related to your JPM. So where the sum of all the elements of JPM is equal to unity. That means if we consider P of A1, so P of A1 plus P of A2 up to P of AR, if we expand this, so that is P of A1 comma B1 plus P of A1 comma B2, so up to how many number of source symbols? BS number of symbols. So this can be expanded up to P of AR comma B1 plus P of AR comma BS. So this is written in the form of your JPM. So where the sum of this, that means P of A1 plus P of A2 plus P of AR, it is equal to unity. That means the sum of all these will be equal to unity. So in general what I can write, so double summation of I is equal to 1 to R, because we are considering both the input as well as the output symbols here. So I is equal to 1 to R and j is equal to 1 to s p of ai comma bj. So this one, so this summation, that is p of ai comma bj, so it is always equal to 1. That means the sum of all the elements of the joint probability matrix is equal to unity. So these are the three properties we have. One is with respect to the input, one is with respect to the output, and another one is with respect to your JPM. That is, the sum of JPM is equal to unity. And if you are summing all the elements of JPM column wise, you are going to get the output symbol. If you are summing all the elements of the JPM row wise, you are going to get the input symbols.